Okay, Agila, Jisha, Smita, Needu, Raj. Okay, good evening, good evening. Okay, Ashwari, Swapna. Sharanya, Kartu Prasannan, Ushna, Siddhika. Okay, I think you can hear me with clarity. And okay, in our previous class, we studied about the hypothesis testing topic. And at that time, I told you that there exist two types of hypothesis testing criteria. One is parametric type and another is non-parametric. Okay. And the parametric method includes normally 4 types of tester such as Z tester, that means normal distribution tester. Then T tester, it is otherwise called a T distribution tester. Then X square tester or chi-square tester. Then another is F tester. 4 types of tests are there. All these are parametric tests. And the fact is that the parametric tests or testing of hypothesis procedures are fully covered in MMPC 5. Okay, here we are giving more thrust to the non-parametric methods. Okay, and what is the difference between this parametric and non-parametric? You should have an idea regarding that. See, the whole data regarding a particular aspect, which is called the population. And studying the entire population is a difficult process. Because of that, we select some samples out of this population and put this sample under study to get an idea of the total or overall population. That means the result obtained from these samples will be generalized to the overall population. But in doing that, certain assumptions are maintained for this purpose. When based on certain assumptions regarding the population mean, population standard deviation, etc., one of the assumptions is that if you are taking some samples from the population, that means if you are taking several samples from a population, the mean and standard deviation of all these samples are same, just because of the reason that it was taken from a single population. Understood? There exists a population. We are taking 3 or 4 sample groups out of this population. And if we are calculating the mean and standard deviation of these samples separately, we will get the same mean for all the groups, all the sample groups, or same standard deviation for all the standard groups, provided because the samples are taken from a single population. Okay, this is the main assumption, but it may not be true always. Okay, when we are conducting test analysis on the basis of this type of assumptions, then it is called a parametric hypothesis. Okay, and if we are not trusting on these type of assumptions, then we can rely upon some other kinds of hypothetical analysis, which are called a non-parametric hypothetic analysis or hypothesis analysis. Okay, so traditional or usual assumptions in the case of parametric hypotheses are not followed in the case of non-parametric analysis. That is the main difference. Okay, now I explain some non-parametric hypothesis. Okay, see, among the non-parametric hypotheses, there are different types of methods, or different methods are used, or different techniques are used to conduct the non-parametric hypothesis analysis. Okay, one of them is one sample test. So it is better to write a heading: non-parametric hypothesis analysis, and among them one method is one sample test. One sample test. Okay, and a famous one sample test method is, if you can see the screen, you can read this: Kolmogorov Smirnov one sample test. You have to write down this heading. Look at the formula. Sorry, look at the spelling: Kolmogorov Smirnov. Kolmogorov, put a hyphen, then Smirnov one sample test. Okay, I think you wrote that heading. Now we are going to solve a question regarding this, and now we are going to solve a question under this, but at first you have to write down a question. I dictate a question. Actually, these questions are in your taken from your materials. Okay.
Sir, can you tell me what is this?
Excuse me.
Can you tell me this what test it is?
This is non-parametric hypothesis test. Okay.
Sir, I understood, sir. No, I ask for this what purpose we look this and what is the definition for this?
Okay. Actually, the parametric and non-parametric tests are conducted for the same purpose. Okay. Analyzing that the particulars drawn from a population of samples are matching with the population or not. That we are testing. Okay. We are taking samples out of population and testing the parameters, testing the peculiarities of this sample, and we are trying to match it with the population. Actually, the test is conducted to measure whether the sample parameters matches with the population parameter. That is the destination you asked. That is the purpose for which we are conducting test. Understood?
Yes, sir.
Okay. So there are several methods used for several techniques developed by several experts, and one of them is Kolmogorov Smirnov one sample test. Okay, that is what I showed you to write down as the heading: Kolmogorov Smirnov one sample test. Now, how this test is conducted? And when you solve a question under this method, you can get more understanding regarding why and how we are doing this. Okay. Now write down the question. A leading, before that, I shared a file with this group, our group. It is from your materials block 3. In its last portion, it consists of several tables. We require such tables at the time of solving the question. Okay. So it is required to look into that table when I asked to do so. It was shared in the group. Okay. Block 3. The name of the file is block 3. Okay. Now write down the question. A leading paint manufacturer. A leading paint manufacturer is interested in developing a new color shade. A new color shade. So he is interested in testing. He is interested in testing 4 different shades. 4 different shades, such as dark, bright, light, and very light. 4 shades are there: dark, bright, light, and very light. Sentence. A sample of 160 customers. A sample of 160 customers were shown these 4 shades. Were shown these 4 shades, and the following results were obtained. And the following results were obtained. 30 liked the dark shade, 45 liked the bright shade, 60 liked the light shade, and the remaining liked the very light shade. So look into that figure clearly. 30 liked dark, 45 bright, 60 light shade, and the remaining very light shade. Okay. The manufacturer wants to know whether the sample result indicate any preference towards the shade. Any preference towards the shade. Okay, that's the question. And somebody asked me, what's the destination of conducting a particular test, or what's the purpose of conducting a test? If you read this question, it will be evidenced that the whole population, that means the whole public, or the customers, prospective customers, a manufacturer intends to approach. The entire customers constitute the population. Okay, but out of that, the manufacturer here just select a sample of 160 customers. Okay, that sometimes the whole world may be his customers, but it is not possible to approach each and every customer to inquire about the merit and demerits of his product. So instead of approaching the whole population, he just picked 160 sample customers and showed his product for getting opinion. Okay, here it is stated that he is developing a new color as a paint manufacturer, and he has idea of 4 types of colors: dark, bright, light, and very light. And he is asking opinion about this color, the preference, whether they prefer or not. He is asking this with 160 customers. Okay, and he got the data that 30 liked or 30 opinions for dark shade. 45 they required a bright shade. 60 preferred a light shade. And the remaining, that means 160 customers are there. 30 plus 45 plus 60, then they should be deducted from 160. I think it is 25. Then the remaining 25, they like a very light shade. Okay, these are the data collected from the population through sampling. Now, what's the destination of this manufacturer? The manufacturer wants to know whether the sample result indicates, that means the opinion given by the sample customers indicate any preference towards a shade. That means whether the whole population is preferring a particular shade in a particular way. That is what he wants to know. On the basis of that, he arranged his overall production. What to produce, that will be determined by this manufacturer on the basis of this analysis. But for this purpose, he has to check the opinions given by the samples matches with the population or not. Okay, here the opinion like or dislike, 30 likes dark shade, means others dislikes that dark shade, isn't it? These likes and dislikes cannot be measured properly through numerical data. How much they like, how much they dislike. It is impossible to measure the likes or dislikes of somebody else, isn't it? So it cannot be, it is not possible, it is actually not possible to measure the phenomena like likes, dislikes, or quality or something else. It is not possible to measure something else. So when there is some parameters which cannot be measured accurately through numbers, we use non-parametric tester to analyze such details. Okay, so if the attributes are measurable by numbers, it is better to use parametric test. And if the attributes cannot be measurable exactly by numbers, the likes or dislikes, we can measure how many likes, how many dislikes. It's possible. But how much they like, or what is the criteria to measure these likes or dislikes? It is more or less impossible. So measuring such qualities, that is what we test with the help of non-parametric test. Okay, here in this question, it is not specifically said to use Kolmogorov-Smirnov method because I didn't given this sentence there because we are doing this under the heading of Smirnov test. Okay, that is why it is not specifically given. But in your question at the time of examination, definitely which method is to be used, that will be indicated in their question. Okay, you have to use that method. The same topics can be solved in different methods. Okay, most of the topics can be solved or analyzed hypothetically with different methods. Now I explain how to solve this question. Okay, so the name of the method is Kolmogorov-Smirnov method. Okay, to solve this, you have to draw some columns. I am showing here. See, one is the attribute given by the manufacturer. That means the dark, bright, light, and very light. It was shown in one column. Okay. Corresponding to that, look at the screen, everybody, and you can see the columns here. If you find any difficulty in seeing this, then just tell me. Here, the first column, which provides the attributes of the manufacturer, means dark, bright, light, and very light. Okay. The next column is observed customers. The next column is observed customers. Okay. In our question, the number of customers the manufacturer observed are given. 30 represents dark, 45 represents bright, 60 light, and 25 very light. Isn't it? How you got this 25? There existed a total number of 160 samples. Out of these 160 customers, 30 likes dark, 45 bright, 60 light, and remaining, which is 160 minus these three. Then you will get 25. Okay. If you have any doubt, just ask me. Okay. Now, the next column is observed distribution. Observed distribution. Okay. Actually, 7 columns are required for that. You have to manage your space accordingly. We have to construct 7 columns. The first column, the attributes, dark, bright, etc. The second column, observed customers. The number of observed customers that is given in the question, which was written here. And the next column is observed distribution. Observed distribution or observed frequency distribution. Observed distribution is otherwise called observed frequency distribution. And it is found out by the number of persons likes dark divided by the total number of samples. Okay, that means 30 divided by 160. In this way, 45 divided by 160, then 60 divided by 160, then 25 divided by 160. Okay, the answer is not here. All of you should find the answer and just show the answer in that column is equal to show the answer here. Okay, I didn't found the answer here. I'm telling the steps how to find this. Observed frequency distribution is calculated by 30, 45, 60, 25, etc. by the total number of samples 160. Okay. Everybody find the answer and show in the column. Anybody who completed the answer, can you tell me for confirming the answer to others? Anybody? 30 by 160.
0.1875.
Okay, 0.1. Next 40. Everybody hear that?
Yes, sir.
0.1875. Next 40 by
0.
160.
0.28.
Point
28.
2813. Then point
0.375.
then point 157.
Okay.
Isn't it?
Okay. Okay, sir.
Okay. All of you got this. Okay. And after getting these answers, next column is observed cumulative frequency. Observed you just write this. Observed cumulative distribution. observed cumulative distribution. Next column, observed cumulative distribution. Listen clearly to avoid confusion. After observed distribution, now we are writing observed cumulative distribution. Okay, how to find out this? The first observed distribution is written here. The first observed distribution is the observed cumulative distribution also. Okay, then the first cumulative distribution should be added with the next observed distribution. Understood? First observed distribution is the first cumulative distribution, and then the first cumulative distribution should be added with the next observed distribution. Then you will get a figure. Okay, now that figure should be added with the next observed distribution. Understand? Then that should be added with the last one. Then you will get all the observed cumulative distribution. Understood? If any doubts, just ask me. Actually, the answers now you got should be cumulated one by one. Any question? Okay, I think there is no question for that. And then the next column is theoretical distribution. Next column is theoretical distribution. Okay, theoretical distribution means actually the probability of all the chances regarding this dark, bright, light, and very light. See, the number of chances are, total number of chances are 4, isn't it? And one can select the first one, and other can select the second one, or third or fourth. Okay, so the probability is same for all the items, dark, bright, light, and very light. All these have equal probability. That is what called theoretical probability. So when the dark one is selected, it is 1 by 4. Out of 4, somebody is selecting the dark. So that is the probability, which is 1 by 4. Similarly, all have equal chances of probability. That is why it is shown here as 1 by 4, 1 by 4, 1 by 4, and 1 by 4. Okay, which is called theoretical distribution. Okay, and now you should find it's a fractional value 1 by 4. 1 by 4 means 0.25, isn't it? So all values are expressed in decimals as 0.25, isn't it? 0.25. If you look into the screen, I'm writing here 0.25. 1 by 4 means 0.25, isn't it? Now the next column is cumulative theoretical distribution. Cumulative theoretical distribution. That is the next column. Okay. In this column, we are cumulating the probabilities. That means the first probability 0.25. That is the cumulative one. Then this 0.25 should be added with the next 0.25. That is 0.50. Then this 50 is added with the next one. That is 0.75. Then this 0.75 is added with the next one, which is 1. Understood? And now I have to say one thing. We found out observed cumulative distribution, isn't it? Observed cumulative distribution. This observed cumulative distribution is called or denoted by Sn x. X is shown in bracket. Sn x. Yes, on its foot n, then within bracket show x. Sn x. Sn x means observed cumulative distribution. Okay. Now the theoretical cumulative distribution. We wrote this theoretical cumulative distribution. It is denoted by F0, actually it is FO, FO, XR. FO, O means observed. O is shown in the foot of F, FO, XR. So we found out Sn XR and F0 or FO XR. Okay. Sn XR is observed cumulative distribution and FO XR is theoretical cumulative distribution. Understood? Up to now, any question? If there is no question, now, okay, Ansari. Okay, thank you. Sidhu, you said no means you didn't understand. That means you want to repeat once more. Sidhu? Okay. See, actually, one more column is required for here. One more column is required here. And it is not written. I am writing it here. That is, next column is, you have to construct one more column, which is F0x minus Sn x. This is the next column. FOX minus Sn x. FOX minus Sn x. I think now it's clear how to find out that column. How to find out that each FOX value should be taken and deduct Sn x value out of that. That means 0.25 minus the cumulative, observed cumulative value. It was not written here. Understood? Each F0 XA should be taken and deduct Sn XA from that F0 XA. That is what literally written here. F0 X means F0 XA minus Sn XA. Okay? You can find the values there. And after finding that value, just tell me that answer. What you got? What is the value of FOX minus SNX? Anybody? Tell me the answer.
Sir, first one 0.063.
For 0.063.
063.
Okay. Next point.
0.22.
Next point 22. Somebody is showing different answer.
Sir, I got 0.032.
0.032. Then third one.
Minus 0.09.
Minus or?
Sir, enku minus set.
Minus. Yes, sir, minus. 0925.
0925.
Yeah. Then 1.25 last.
Then 1.25.
25.
See, F0 extra is taken first and we deduct SNX out of that, isn't it?
Yes, sir.
Okay.
So can you please show the values once again?
Point 063, 0.032, minus 0.0925, then 1.25. Am I right? Is the last
Yes.
one 1.25?
No, sir. Last answer.
So it is 0.156 minus 1.
1 minus. Last one is 0.01. Isn't it? Last one is 0.01.
0.01.
Yeah, 0.01. Okay, now I explain the criteria. Listen, everybody. Listen here. We have to consider the highest value of the f0x minus snx. Okay. That is called a D value. Look at here. D is equal to the maximum of f0x minus snx. I written it here. D value means D is equal to the maximum of f0x minus snx. You found out all the f0x and snx values, and which is the maximum value, that is considered as the D value. Okay. Then which is the maximum one here?
1.25.
1.25. See, these are the answers in the 0.063, 0.063. 0.063 is the maximum item. Yes, yes. There is no, only 4 figures are there. Look at here, 0.063, 0.032, minus 0.0925, then 0.01. Okay, out of which the highest item is 0.063. So the D value is which the maximum of f0x minus snx. That is the D value, which is 0.063. Okay. And this is actually called a calculated value. This is actually called the calculated value. Okay. And we have to look into a table called a D table. D table. The table is given to you. I already told you that file was shared to you. The name is block 3. And in that, if you take on its last portion, I think it is after page number 41. If you are taking that, if you are not able to take that file now, then it's not no issue. I tell you the value, and you can refer later. Okay. Okay. Now we have to consider how many sample items are here. Here the sample items are 160, isn't it? If the sample items are more than 35, if the sample items are more than 35, we have to take the D table and apply the value like this. Look at here, D is equal to 1.36 divided by root n. D is equal to 1.36 divided by root n. Means 1.36 is static value, constant value, and 1.36 divided by, what is the value of n? It is 160. So 1.36 divided by 160, root 160. Okay, then find the value of that. 1.36 divided by root n.
Can you please repeat that? 1.36, how are we getting?
1.36 divided by root n is available in the D table. Okay, if you cross check the D table, you can see that 1.36 divided by root n in the D table. Okay, since the number of samples are above 35, you have to write that since sample size is more than 35, since the sample size is more than 35, the D table value is equal to, 1.36 divided by root n. Okay, that is 1.36 divided by root 160. You should find the value of root 160 and divide 1.36 by that amount. Okay. Anybody got the amount? 1.36 divided by root n.
Is it 0.107?
0.1075. Okay. 0.1075. Okay. Then that is the table value, which is called a table value. We already have the calculated value. We already have the calculated value 0.063. Okay. D value 0.063, and now we got the table value, which is 0.107. Okay, 107. Now the decision is, if the calculated value is less than table value, we accept the hypothesis. So you have to write like this: since the calculated value 0.063, since the calculated value 0.063 is less than the table value, 0.107, we accept the hypothesis. Then what is a hypothesis? Next line. H0 is equal to H on its foot 0, like this, H then 0. This is called a null hypothesis. H0 is equal to, what is asked in the question? The sample results indicates the preference towards the shade. The sample result indicates the preference towards the shade. That means the whole population behave like the samples. That's the conclusion. The whole population behave like the samples. That is what's meant by this hypothesis. Okay. If anybody required to explain any steps, if you want to explain any steps further, anybody? Under D value. No, you have to bring this D table with you. Usually D values are not given along with the question. So it is better to keep the D table. Several other tables are also there. T distribution table, Z table, chi-square table. Along with this D table should also be kept at the time of examination. Okay.
Sir, D table is
excuse me.
sir, D table is available in logarithms book. or we have to buy it separate?
Different variants of logarithm books are available. You have to ask for statistics logarithm table. Okay, only on statistical logarithm statistical books it will be available. Okay, there are. Can you repeat? I am explaining the table heading once more. Somebody is asking the table head once more. See, here the first one is attributes. That means attributes given the question, which is dark, bright, light, etc. Next is observed customers. It is also given in the question 30, 45, 60, 25. And then is observed distribution. Observed distribution, which we found out by each number by total sample. That means 30 by 160, 40 by 45 by 160 accordingly. And then observed cumulative distribution. Observed cumulative distribution. Okay. Then next is theoretical distribution, which is the probability. 1 by 4, 1 by 4, each one has equal probability here. That is why theoretical distribution is 1 by 4. And the last one, next is cumulative theoretical distribution. Cumulative theoretical distribution. See, the observed cumulative distribution is denoted as Sn xa, and the theoretical cumulative distribution is denoted as F0 xa. Then the last column is F0 x minus Snx. F0 x minus Snx. I think it is clear. The headings are clear.
I just have a doubt. How do we take the D value from the table if we are taking the paper? Can you please say?
On the basis of number of samples given, we have to select that. If the number of samples is more than 35, in the D table, above 35 is there.
Yes,
on its left hand side, above 35. And on this above 35, you have to look at in usual, if nothing is mentioned in the question, 5% significance level is to be taken. If nothing is mentioned in the question, 5% significance level is to be taken. And horizontally take above 35 and vertically look into 5% significance level. The intersecting point is the value. Okay.
Okay, sir. Okay.
Okay. And in the intersecting point, you can see 1.36 divided by root n. That is what there in your table. If you look into that, you can see 1.36 divided by root n. Then we apply the value of n there and find the table value. Clear?
Yes, sir.
Okay. Now I think there is no further question regarding this. And even if anybody has to clear any doubts, just ask me now. Okay. Next, we are looking into another test called runs test. So write another heading, runs test, RUNS, runs test for randomness. This runs test also asked for several times in your previous questions. This runs test is used to measure the behavior of the customers or behavior of the people regarding to a particular thing. Okay. But it's a data collection and tabulating style is quite different from that of the Smirnov model. And I explained that with the help of a question. Runs test for randomness. Okay. Now write down a question. Write down a question. In order to study the arrival pattern of customers, in a supermarket, comma, the manager noted the arrival pattern sex wise, male and men and women, sex wise men and women, sex-wise men and women, comma, M for men and W for woman. M for men and W for woman. The sequence is now everybody look at the screen. The sequence is given like this. MM, then WWW. Can you see this? Your question looks like this. So you should write this properly and clearly. It starts from MM, then 3W, then 1M, then 2W, then 2M, then 4W, then 3M, then 2W, 2M, 1W, 3M, 3W, 2M, 2W, 2M, 2W, 1M, 2W, 2M, 2W, 1M, 2W, 2M, then 2W. I think you finished with this. So the number of M and W are very much important here. Actually, most probably in your question, it will not be given in blocks. It will be given in a single line. You have to identify this. Okay. But for your convenience and better understanding, I wrote it in block as M and W. Okay. Now, we are actually, what is the question? You should properly understand the question. In order to study the arrival pattern of customers, how customers are coming into the shop, the supermarket, in a supermarket, customers are coming into, isn't it? The manager noted the arrival pattern sex-wise. That means some men are coming, then after that some women are coming. In this way, men and women are alternatively coming into that. Then when 2 men come into the shop, after that 3 women are coming. Okay, then after that 1 man is coming. After then 2 women are coming. That is the arrival pattern. That means the incoming pattern of the men and women in the supermarkets. Got that? And the actual sequence is given here. The actual sequence is given here. He wants to find out whether this pattern is random or not. That is what you have to write on one more line after this, after completing this sequence as a paragraph. Just write a line. Test whether the arrival pattern is random or not. Arrival pattern is random or not. If something is happening without having any particular without having or following any particular strategy, then it is called random. Okay, and if something is following on the basis of some strategy, then that is not called it's actually planned one. There is no randomness in there. So whether this is randomly happening, the arrival, that means the incoming of the customer is randomly happening or not, that is what asked in the question. Okay, and just by looking into the question, you can easily identify how to solve this, because only a random question is looking like this. Okay, if the question is if the question looks like this, then definitely you have to run. That means you have to test with a run test for randomness. Now I explain the steps or procedures used to test this randomness. Listen, there are some formulas, and we have to use that formula for this purpose. Before that, each set is called each run. For example, In first case, 2 men are arrived, which is 1 run. After that, it changes to women, that is second run. Then again men, third run. Then again women, fourth run. In this way, how many runs are there? Understood? The first MM, which is called 1 run. Then it changes to women. Then second run. Then it again changes to men. Then third run. On the basis of the changing tendency, we calculate the run. That means the 1 run, 2, 3, 4, 5, 6. In this way, we have to calculate runs. And all of you should find how many runs are there in the question. How many runs are there in the question? (24). Ansana Shijima says Akila. Okay, 24. 24 runs are there. So run is denoted by the letter R. Run is denoted by the letter R. Here R is equal to 24. Okay. Now count how many M's are there in the question. How many M's are there in the question? M. How many? 1, 2, then 3, 4, 5. In this way, how many M's are in the question? Count that. How many M's are there in the question? Uh, 23. Okay, Shrida says it is 23. Okay, 23. So N1 is equal to 23. N1 is equal to 23. Okay. Now, how many W's are there in the question? Count the W's. Count the W's. (27). Shruti says 27. So N2 is equal to 27. Okay. And the information is correct. N1 is equal to 23. N2 is equal to 27. R is equal to 24. Is it clear now, everybody? Now we are going to apply this into a question. Actually, Z test is used to find. Okay, Ranjisha. We have to use Z test here. Means Z test is used here to test the hypothesis, and the formulas used to find the value of Z is stated here. Look at here. Say the core formula is Z is equal to, we are going to find out the Z value, normal distribution value or Z value. Z is equal to modulus R minus ER. R should be shown in the bracket, ER. If you look into this, then you can clearly understand. Z is equal to, modulus means 2 lines are here, so the bar, 2 bars are here, bar R minus ER bar. That means modulus. Modulus means without a sign. The sign is positive or negative is irrelevant. That is here by this modulus R minus ER. Okay, divided by SDR. R is shown in the brackets. R minus ER divided by SDR. So this is a core formula. So what are the requirements here? We should have R. Now the R value is here, found out that which is the R value is here, which is 64. Okay. Then we have to find out the ER. How to find out this ER? In order to find this ER, we use another formula. Look here. If you listen properly, then you can do this very easily. ER is equal to E within bracket R. ER is equal to 2 N1 N2 divided by N1 plus N2 common as a common plus 1. That means 2 N1 N2 divided by N1 N2. After solving this, you should add 1 with the answer. Reading this once more, 2 N1 N2 means 2 into N1 into N2. Okay. Then denominator N1 plus N2. After solving this, the answer should be added with 1 plus 1. Got it? That is how we find out ER value. Okay. Now, then again come to the core formula, R minus ER divided by SDR. Isn't clear? How to find out this SDR? Another formula is there to find SDR. SDR is equal to SD, show R within bracket. SDR is equal to 2N1 into 2N1 into minus N1 minus N2. This 2N1 N2 minus N1 minus N2 should be shown in the brackets. So I read the line numerator once more, 2N1 N2 into 2N1 N2 minus N1 minus N2. Understood? The whole divided by N1 plus N2 the whole square, N1 plus N2 the whole square into N1 plus N2 minus 1. N1 plus N2 minus 1. So that's the formula. Okay. Now explain all the formulas. I think all of you written this formula clearly. Okay. Now I already told you that we are using Z table. While using Z table, the significance level or level of significance is 5% and degree of freedom is infinity. Okay. So you have to write this also. If nothing is mentioned in the question, the level of significance is 5%. 5% means 5 by 100. That means 0.05. Okay. The level of significance of 5% and the degree of freedom infinity. And degree of freedom infinity. So these are the things we require to find the values. Okay. We are setting the null hypothesis. H0 is equal to, right? H0 is equal to the pattern of customers. The pattern of customers are on random base. That means there is no pre-planned arrangement for this. They are coming into on a random basis. Okay. That is our theory. We are going to check that. And in order to check that, at first we find out what? ER. ER means 2N1, N2 divided by N2 plus N2 plus 1, isn't it? Now the value of N1 and N2 are available to you. N1 is equal to 3 and N2 is 7. Just to put the values in this and find the value of ER. Then listen. Secondly, find a SDR. In order to get SDR, whole root of 2N1 N2 into N1, 2N1 N2 minus N1 minus N2, whole divided by N1. And you know what the value of N1 and N2. Just apply these values and find the root square of this. Then you will get the SDR. Okay. After getting these values, just to put these values in the Z equation, means R minus ER divided by SDR. Here the numerator is modulus. That means even if the value, when we deduct this value, sometimes you make it negative. Then don't mind that. The negative or positive, that is irrelevant. That is what indicated by this bar D bar. So bar R minus ER. Okay. Anything to repeat? If you want to have clarity with regarding anything, just ask me. Otherwise, apply the values into the formula and find the answer. ER value, SDR value, and then Z value. Find the values now. If anybody want to have any clarity, just ask me. Tell me the answer of ER, then SDR and Z. Sharanya says 25.8 as the ER value. Okay. Ammu also says that. Sujima, 25.8 is the ER value. Okay. Okay, Jisha. Okay. Now find the SD. So everybody listen. 25.8 is the ER value. Now find a SDR value. 3.48 is the SDR value. 3.48 is the SDR value. Okay. 3.48. Then apply the values in Z. Z value is 0.53. Smita Pillai says Z value is 0.53. Point 5 2 or 5 3 Saranya. Okay, 5 2. 5 2 also correct. Saranya, Resha. Okay, it's correct. Did everybody got the answer? Can I proceed? Okay, Mo. Okay. Now listen. Okay. Now listen. We are using Z table, isn't it? Z, and in Z table, we should look into 5% significance level. Means 5% means 5 by 100. That means 0.05 significance level. And degree of freedom is infinity. Okay. Now, can you see this table? This is T distribution table that we used in our previous class also. This is T and Z distribution. Both are in the same table. T distribution. Can you see this? T distribution and Z distribution. Both are here. And Z value is available in the left hand last figure. Can you see this infinity? INF. INF. Okay. So,
page number?
Excuse me, Amu?
Page number 7.
Page number 7. This is not. This is a statistic table. This is not in your book. Okay.
Okay, sir.
Okay. This is T distribution table. When you take the T distribution table, on the left hand side, the last item is INF. INF means infinity. Okay. And the horizontal infinity. And you can see 0.05 here. Can you see this? 0.05 here. And vertical to this 0.05 and horizontal to this infinity, the meeting point is 1.96. The table value is 1.96. I explained how to find out the Z value. And you should remember that always in Z test, usually the significance level is 5% and degree of freedom is infinity. Okay. That is why, as per Z table, most of the time the answer is 1.96. Otherwise, the significance level changes. If in your question it is asked to use another significance level 10% or 15%, usually it is not asking. But if it is asked, then the value will change. Otherwise, always at a 5% significance level and infinity degree of freedom, 1.96 is the table value always. Okay. Now, you should write, see, you put Z, the value of Z as 0.53. That is what called the calculated value. The calculated value is 0.53. Okay. Now the table value we got as 1.96. Okay. We are writing this as a conclusion. Write this, as I said, see, at a 5% significance level, at a 5% significant level, the table value is Z table value. The Z table value is 1.96. 1.96 with a degree of freedom infinity. With a degree of freedom infinity. Okay. So the table value is 1.96. Now write the conclusion. Since the calculated value 0.53, which is the 0.53 is the value, which is calculated value 0.53 is less than the table value 1.96, is less than the table value 1.96, less than the table value 1.96, comma, accept the hypothesis. Accept the hypothesis. That means when the calculated value is less and the table value is higher, then we should accept the hypothesis. Otherwise, we reject the hypothesis. Okay, that's all with this question. And if you have any doubt, ask me now. If anybody have a doubt regarding this, just ask me. Is it clear or not? Yes or no?
Yes, sir.
Clear,
Okay.
sir.
Okay. So that is with this run test for randomness. Okay. Now I explain another one. Say, in the last class, we solved a previous year question paper to check whether the mean is from the same population. That means when the samples are from the same population by using T table. By using T table. You remember that the figures are two columns are there. The figures are A, B, 51, 68, 90. That is the figures shown in the first column. See, the same question. Okay, the same question is now solving through a non-parametric method. Okay, the question that we solved solved by using the T distribution, which is a parametric method. Now we are using a non-parametric method to solve this. The same question. The name of the tester is Mann-Whitney U tester. Write down this heading. MANN, Mann-Whitney, WHITNEY, Mann-Whitney U tester.
Sir, one more test was there now, sign test in example.
Yeah, there are several tests remaining. Sign test, several
No,
other
no,
tests.
actually the previous year question paper, in one question paper, one sample sign test was asked.
Yes, we can solve that later. Okay.
Okay.
Okay. So write down this heading Mann-Whitney U tester. Okay. Actually, this man-weight U-test is conducted in 3 ways on the basis of the number of samples under study. When the number of samples under study is below 8, a particular method is used. And when it is in between 8 and 19, another method is used. And when it is more than 20, a third method is also used. Okay. So, depends upon the number of items, the number of samples, the method is method differ, the testing method differ. Okay. Here, for better understanding, I am using the third type one. The third type one, because of time limitation, I am taking the important things first. That is what I am taking this one. Okay. After that, if there is much time, then we can discuss the other topics also. These type of questions are repeatedly, continually asking several question papers. That is why I am telling about this. Here, I am dealing with this man-Whitney U-test when the number of samples are more than 20. Okay. That method is actually using here. Write down a question for getting explained. Following are the scores obtained by. Following are the scores obtained by two students in a competitive exam. Two students in a competitive exam. Test whether the two group belongs to same population. Two group belongs to same population. So two groups are there. That means two columns are there. Just look into the screen. A, B, two columns are there. Okay. In the first group A, write these figures: 51, 68, 90, 81, 30, 46, 99, 98, 11, 6, 19, 43. Okay. The B group, the figures are 95, 82, 65, 85, 65, 81, 50, 60, 15, 5, 35, 32. The same question was solved under T distribution last class. Okay, I think you remember that. And if nothing is specifically asking in your question to which method is to be used, then you can do by using any method. There's no issue. Okay, and according to your convenience, you can use t-test or that means the parametric or non-parametric. Okay, t-test is actually a parametric, and now this method is non-parametric one. The same question is solving through non-parametric here. Okay. So now listen the further steps. See, actually we have to rank the whole two groups on the basis of their ascending order. Okay, that means consider the two groups as one and find which is the least one and which is the next one. In this way, you have to find out. You have to arrange the whole thing, rank the whole thing on ascending basis. Okay. sometimes it will be difficult, or in the ranking process, you may get confused, or there may be chances of errors. Because of that, it is better to arrange the two groups in ascending order. Then it will be more convenient to do this answer. First, A group should be arranged in ascending order. I arranged here this in ascending order. The second B also arranged in ascending order. Then it is better to arrange the two groups in ascending order for the purpose of ranking. Okay. So everybody arrange A and B in the ascending order. For example, A in the group A, which is the least one, 6. That is written first. Which is the next one, next highest item, 11. That is written here, 6, 11. Then next item, 19. In this way, I arranged the whole data in the A group on ascending order. Similarly, B also arranged in ascending order. So everybody write the figures in A and B groups in ascending order. Do that fast. Get all the figures arranged in ascending order. And I'm reading the first column. Check whether it is correct or not. 6, 11, 19, 30, 43, 46, 51, 68, 81, 90, 98, 99. Okay. In this way, B group is also arranged 5, 15, 32, 35, 50, 60, 65, again 65, 81, 82, 85, and 95. in the R1 column. And if we are ranking a figure in the B column, show that rank in the R2 column. Okay. So we should use R1 and R2 column as per our requirements on the basis of the ranking. Okay. Anywhere, the procedure is that following the least one. Next list in this way. So 5 is the first list, ranked 1. 6 is the next list, ranked 2. Then 11, third one, ranked 3. Then 15, ranked 4. Then 19, ranked 5. Then 32. Sorry, 9 after 19, the list is 30 in the same column. After 19, in the same A column, the next list is there, 30. So we have to rank that, which is 6. And then 30, the next list is in B column, which is 32. That is why we jumped to B column and the rank is 7. Okay. After that, the next list is 35 in the same B column. So it is ranked 8. After 35, the next list is 43. It is ranked 9. Then next list is in the same A column, which is 46, isn't it? So it ranked 10. Then next list is 50 in the B column, ranked 11. Okay. Then next list 51, which is in the A column, ranked 12. Next list after 51, it is 60 in B column, which is ranked 13. Okay. Then after 60, the next item is, next list is 65 in the same B column, which is 14. So wait. Sorry. The next list is 65, repeat for 2 times. Okay. Listen carefully. After 13, 60, ranked as 13. The next item 65 repeats for 2 times. You notice that? So we have to provide a 14th and 15th rank to both these items equally. Understand? If you rank this one, it will get a 14th rank. Then again there is a 65. It will get a 15th rank. So 14 plus 15 divided by 2. The rank should be split at 29 divided by 2. That means 14.5. Isn't it? So the first 65 is to be ranked as 14.5 and the next 65 also ranked as 14.5. Understood? If there arises a tie, then divide the ranks to the items correspondingly. Okay, here 65 repeated for 2 times and it represents the 14th rank and 15th rank. Then 14 plus 15 divided by 2. Then 14.5 should be given to 65, the first 65 and second 65, 14.5. Any doubts? Okay, now I'm continuing. After 65. After 65, the next list is 68, isn't it? Now the 14th and the 15th ranks are shared. Then remains the 16th one. So we provide the 16th rank to 68. Then after 68, 81 is the next list and 81 appears 2 times here. So we have a 17th and 18th ranks, which is to be divided among these. 17 plus 18 divided by 2. Understood? 17 plus 18 divided by 2. Which is 17.4. Am I right? So the first 81 also given 17.5. The next 81, 17.5. Clear? So 17th and the 18th rank are gone. Now the next list is 82, given 19th rank. Next is 90, sorry, 82, 19th rank, which is in R2. And the next 90, which provides the 20th rank. One second. After 80 to 85, is it 16.5? 17 plus 18. 17 plus 18 means 35, isn't it? 35 by 2.
17.5.
17.5, right? 17.5. Say after 82, it is given 20th rank. Okay. After 85, then comes 90. 90 is 21st rank. Then 95 is here. 95 is here, which is 22nd rank. Okay. Is there anybody having doubt regarding this ranking process? We consider the two groups as so two groups together to get it ranked. Okay. So we have to jump from A and B, jump between A and B to find the ranks, and we have to record these in R1 and R2 column respectively. That is what the difficulty here. And that is why I asked you to arrange the things in ascending order. If you didn't arrange these things in ascending order, sometimes you may have some mistakes in ranking process. That is why if you done after getting it arranged in ascending order, then it is better to place the ranks in the respective figures. Is it clear? Okay, since there is no question from you, okay. Thank you, Karthika, Renjusha. Okay, thanks for response. Now we have to look into the formulas and hypothesis analysis. Okay. See, here also we are using Z table. Here also we are using Z table. So the formula for Z is equal to U minus EU. This EU is shown in brackets. EU. In case of EU, U is shown in bracket. Okay. Then divided by SD in bracket U. So U minus EU divided by SDU. That is the core formula for Z usage of Z test. Z is equal to U minus EU divided by SDU. Wrote the formula. And in order to apply in this formula, we require U, EU, and SDU, isn't it? So we have to find all these figures. Okay, I show you how we can find out that. And before that, we have to use level of significance 5% and degree of freedom infinity. In Z test, I already explained that in Z test, infinity is the degree of freedom always, and if nothing is specifically mentioned in the question, level of significance is 5%. Okay, we use Z table. You have to calculate the values in the table also. So now I explain how to find this U, EU, and SDU. See here, U is equal to, other formulas are here, U is equal to N1 N2 plus N1 into N1 plus 1 divided by 2. This should be written after plus. Okay. So at first you have to multiply N1 and N2, then do this N1 into N1 plus 1 divided by 2. Okay. Then minus R1. Then minus R1. Okay. And then EU is equal to E within brackets U. EU is equal to N1 N2 divided by 2. N1 N2 divided by 2. Okay. Then SDU is equal to root of n1 n2 into n1 plus n2 plus 1. This n1 plus n2 plus 1 should be in brackets divided by 12. It is in the whole root. n1 n2 into n1 plus n2 plus 1 divided by 12. These are the three formulas to find out u, eu and sdu. After finding this, you can apply the value in z. Okay. But there is one more figure which is r1. R1 means the total of R1 column. The total of R1 rank column, R1 column, which is called R1. Somebody showed me the total of this R1 by didn't notice that. So when you take the total of R1, you will get R1 value. But all of you should total both the R1 and R2 column. Everybody, as the next step, I think you noted these formulas. If you noted this formula, and if anybody wants to repeat this formula once more, then tell me. Otherwise, if you noted this formula, then next step is total R1 and R2 column. Find the total of R1 and R2 column. Everybody. R1, R2 is 151.5. Okay. R2 total is 140. R1 is 148.5. Okay. Okay. 148.5 and 151.5. So I think everybody got the total of R1 is 148.5 and the total of R2 is 151.5. Okay. Now I explain the criteria regarding this. Usually the least total item is to be considered. The least total item is to be considered. Here the least total is R1. That is why we are considering R1. Just look into this formula, this this U formula. U is equal to n1 n2 plus n1 into n1 plus 1 divided by 2 minus R1. Okay. If we are considering, or if there is the least item is R2, the formula will get changed. Okay. I read the formula. U is equal to n1 n2. It's okay. Plus here instead of n1, if we consider R2, here it is n2. Okay. n2 into n2 plus 1 divided by 2 minus R2. Okay. That means, since the least total is coming to R1, we are considering R1 here. Okay. But if the least total is for R2, you have to consider R2 for calculating U value. Then how this formula will change? U is equal to n1 n2 is common plus instead of n1, if you have to take a R2, then the n1 is changed to n2, n1 plus 1 is changed to n2 plus 1 divided by 2, and minus R1. Instead of R1, it will be R2. Not that. Here we are considering R1 only. That is why we are following this formula. Okay. Now everybody find the value of U, EU, and SDU. Since all the values are available, how many numbers are there in N1? That means in A group, how many items are there? 12 items, I think. It is 12. And similarly, B group also 12. So N1 and N2 are 12 here. N1 and N2 are 12. N1, N2 each are 12. R1 value is available. We already found out the R1 value as 148.5. Okay, so every value is available here. Just apply these values in U, EU, and SDU formulas. Find the answers. If possible, show me that 72.5 is the 73.5. I think it is better to recheck that answer. N1, N2, 12 into 73.5. Alex Solomon says the answer is 73.5. Say I'm once again N1, N2 means 12 into 12 plus 12 into N1 plus 1. That means 13. 12 into 13 divided by 2 minus R1. See, here 12 into 12, 144 comes into. Then after doing this, what's the amount? It should be added with this. And then last 73.5. Okay. Everybody says 73.5 is the answer of U. Okay. Now find the EU value. What's the EU value? EU value 72. Okay, okay, Amu, Smita, EU value 72. Okay. See, EU value N1 is 12 and N2 is also 12, isn't it? 12 into 12. 144 divided by 2. Okay. Okay, okay. Now, SDU value. What is the SDU value? SDU value 17.32. 17.32. So, I think all of you got this answer. The values of 3 items. I think it is U is 73, isn't it? Okay. If you got these answers, then apply these values into the Z table. In Z table, U minus EU divided by SDU. All values are here. Just apply these values and find the value of Z. Now, Z is equal to 0.98. 0.987. Is it? Value of Z. Anybody once more say the answer of Z? What is the value of Z? 0.087. Smita Pillai said 0.087. I think somebody earlier showed up 0.987. Who is that? 0.087 is the answer, I think. Did everybody get that answer? 0.087. Okay, okay. Then 0.087 is the answer of Z. Okay. Now we are applying the table value. See, at a 5% significance level and degree of freedom infinity, we know that Z table shows value 1.96, isn't it? In the last problem also we checked in this value and found out this value as 1.96. Okay. So the calculated value is 0.087 and the table value is 1.96. Okay. We are going to write down this. Just write this. At a 5% level of significance, comma, and degree of freedom infinity, comma, the Z table value is 1.96. The Z table value is 1.96. Okay. Next line. Null hypothesis H0 is equal to the two groups belong to same population. the two groups belongs to same population. So that is what we have to prove. Whether the two groups have two sample groups have same population are coming from the same population. That is what we have to prove. Now, write this sentence. Since the calculated value is the 0.087, isn't it? That's the Z value. Z value is the calculated value. I think it is 0.087. Since the calculated value 0.087 is less than the table value, 1.96. We found that the table value is 1.96, isn't it? The table value 1.96. The null hypothesis is acceptable. The null hypothesis is acceptable. That is the two samples represent the same population. The two samples represent the same population. See, I just remember you that the same problem was solved under t-test also in our last class. Okay. You can go through these solutions and check the differences, how we solved these two items in the two methods. In parametric model, we use the t-test for that. And another thing is that in the case of non-parametric model, this test, this Mann-Whitney U-test is actually an alternative of t-test in the parametric method. So we can solve the same thing in any of the two things, t-test and U-test. Okay. When t-test represent parametric model, U-test represent non-parametric. That's the difference. We can solve. We can use any of these two techniques. And if nothing is asked particularly in your question, you can do any of these two techniques. There is no issue. And for research methodology paper, it is better to use non-parametric methods for almost all questions. If it is possible to solve with non-parametric models, then do that with that technique. That is because the research methodology paper is giving more importance to non-parametric area. Okay. And while doing with this MMPC 05, that means quantitative technique analysis, in that paper, the importance is given to parametric model. So there we can use the parametric test. So if it is possible, use this non-parametric in the research methodology. Okay. So that's all with this question. And anything, yes, Amu, are you going to ask anything, Amu?
I said okay, sir. It's
Okay.
clear.
Okay. Anybody have any issues with this question? Then tell me now.
Sir, I couldn't. Yeah. Go ahead.
Okay. I know that it is nearly 60 or 70% clear with this by solving one or two questions in a particular area. And you have to practice these things with yourself, then only you will get a clear idea regarding that. And when you look into that once more, then you feel that it is more easy. Okay. Sometimes most of you are doing these type of questions for the first time. There may be a chance of some difficulty. That is why I'm asking repeatedly to you that if any doubt, ask me. Okay. And if you are if you ask now, then it will be possible to clear this instantaneously. That is why I'm asking. And if there is no question regarding this question, then we can move to the next one. The time is over, then it's no issue. I'm moving
Yeah,
to
sir, I joined a bit late, sir. So is there any possibility that I get the questions and the other solutions discussed
are
earlier?
you joined in the MMPC 15 group?
Yes, sir.
Then request any others to put the photos of these notes in the group. Okay.
Sure, sir.
Ask for the photos. They will cooperate with you. No issue. I think they will cooperate with you. Most of them, most of the students have these solved answers on the questions, and they put in the group. Ask them.
Sure,
And I
sir.
request everybody to, if somebody asks any question or answer, please cooperate with them and support them. Okay.
Thank you so much, sir.
Okay, that is why I formed that group. That's for purpose I formed that group. See, now we are moving to the next one. Say, somebody asked me about the sign test. So I am explaining the sign test now. I think it will take 5 more minutes. If there is no issue, I am explaining that. Okay, then write the heading, the sign test. Okay, now, okay, Mushina. Okay. So write a heading, sign test. This is another technique to test a hypothesis, and we can explain this with the help of a question. Write down a question now. So the question is here: to determine the effectiveness of a new traffic system. The effectiveness of a new traffic system. The number of accidents that occurred. The number of accidents that occurred at a random sample of 8 intersections during 4 weeks before and after the installation of a new system given below. Then you have to write 9 and 5. A group of information is given, right? 9 and 5, comma 7 and 3. 7 and 3. Then put comma in between this. Okay. 3 and 4, comma 16 and 11. 16 and 11. Then 12 and 7. Then 12 and 5. Then 5 and 5. Then 6 and 1. 6 and 1. Sentence: use sign tester. At a level of significance. Alpha, there is a sign for alpha. Do you know that? Alpha is equal to 0.10. Alpha is equal to 0.10 to test a null hypothesis. Say, the name sign tester here means we use only the signs plus or minus. Okay, the importance is given not to the figures, but it's a sign plus or minus. That is why it is called a sign test. Clear? And I explained the question. I am providing a clarity to the question. Say, we are going to find the effectiveness of a new traffic system. a new system is installed after 4 weeks. That means at first a study is conducted in 8 intersection points regarding accidents, and then a new system was implemented there, and after 4 weeks again the data was collected. Then we got this data 9 and 5. That means 9 accidents were happened before 4 weeks, and after the installation of this system then it reduced to 5. Okay, in this way 8-point accidents details are given. Okay, that is what regards to this question. Now I tabulated this into 2 columns, before installation and after installation. 2 columns are there. Okay, before installation the number of accidents 9, and after accident it was 5. That is given in your question as 9 and 5. Okay, then 7 and 3. So before installation it is 7, and after installation it is 3. So I grouped this whole data like this: 9, 5, 7, 3, 3, 4, 16, 11, 12, 7, 12, 5, 5, 5, and 6, 1. Is it clear? If you are okay with the tabulation, okay. If you are okay with this tabulation, now I explain. Okay. Now check the signs. Here we are going to check the sign. See, we are taking the difference between the first and second. We are deducting the second one from the first one. Okay, we are deducting the second one from the first one. Means 9 minus 5. It will be a positive sign, isn't it? So I put a positive sign here. Then 7 minus 3, again positive. Then 3 minus 4, it's negative. Then 16 minus 11, positive. 12 minus 7, positive. 12 minus 5, positive. 5 and 5, there is no sign. Okay, and 6 minus 1, positive. Okay. Now, how many positive signs are here? See, actually there is a total of 1, 2, 3, 4, 5, 6, 7, 8. 8 trials are there. 8 trials are here actually, but one is tie. So we have to eliminate that. So as it is 0, that means 5 and 5, as there is no change, we are eliminating that, and we just count the others only. Okay, that means 7 we say that 7 trials are there. 1, 2, 3, 4, 5, 6, 7. 7 trials are there, out of which 6 are positive and 1 is negative. Am I right? You understood?
Yes, sir.
Yes.
Yes, sir.
7 trials are there, out of which 6 are positive and 1 is negative. That means out of 7 trials, 6 successful events happened. Okay, out of 7 trials, 6 successful events happened. This signs are reads. This signs indicates that we conducted 7 trials, out of which we succeeded in 6, failed in 1. That is what indicated by this minus. Okay, and here we use binomial probability distribution. Binomial probability, when 2 things are data are compared and collected and their probabilities are mutually considered and analyzed, that procession or that distribution is not binomial probability distribution. Just remember this thing only. In this case, sign test, we have to use binomial probability distribution should be used. Okay. In the case of binomial probability distribution, there is a table which says about the total number of trials and the number of success events. Okay. In the material that I sent to you in the group, there is a table called binomial distribution table. Okay, binomial distribution table. Just a second. I think it is available. Just look into that. Just a second. say the table looks like this. The table look like this, but all the elements are not here in this table. There is one more table, is only a simple table is here, but you have binomial probability distribution table. Okay, in this table there will be three elements. One is probability. Since the table is not here, I am just explaining how it appears. Say the table look like this. Here probability, that means P is marked here. That means 0.01, 0.02, 0.03, in this way 0.05. In this way, probability is marked horizontally. And on left side, the total number of trials, and the successful rates are recorded there. The total number of trials and successful rates. Number of trials, that will be n, and probably the successful rate is given as r. Okay, so if 7 trials are made, that means n will be 7 and r will be, there will be 1, 2, 3, 4, 5, 6. 6 columns will be there. You have to look into horizontal to 6 and vertical to 0.5. That means probability here always is, like, if nothing is mentioned in your question, probability is taken as 1 by 2. 1 by 2 means 0.5. Okay, probability should be taken as 0.5. So just look into the table, vertical to the 0.5 column and horizontal to N7 and R6. N7 means number of trials is 7 and the successful rate is 6, isn't it? So N7 and successful rate is 6. The intersecting point will be a value. That is what called a table value. Understood?
So N7 value will be N will also be having 1 to 7 numbering there, right?
Definitely, because the table on throughout N1, N2, N3, in this way, there will be several trial rates will be there, isn't it? Out of which you have to look into N7. And under 7, the number of success rate R is also given 1, 2, 3, 4, 6, and you should note the sixth value. Okay.
So we should take under 0.05 or 0.5.
0.5. 1 by 2. 1 by 2 means 0.5.
Okay.
Probability should be considered as 1 by 2. That is 0.5. You should the vertical is
The
0.5.
reading should be under 0.5. No.
Excuse me.
The table reading should be under 0.5.
0.5. Yes, 0.5.
Okay.
Okay. I think now due to the absence of this table, exact table here, that is why I am showing like this. I think you understood this. And if you look into the binomial probability table, you can make it clear. Now, find the value, find the table value. Okay. And verify that here in the question it is given alpha value is 0.10, isn't it? See, in this way, alpha value, this is alpha symbol, alpha value is 0.10. Okay. If the found out value is below this alpha value, the hypothesis should be rejected. That is to be noted, very important. Then write this. Write this. The value as per binomial distribution table so I corrected this as if the value as per binomial distribution table, if the value as per binomial distribution table is less than the alpha value, the hypothesis is rejected. That means otherwise accepted. Otherwise, acceptance. Okay, so sign test is actually an easy one. Just to take the sign and count the number of positive signs and apply the figure in the binomial distribution table. Okay, there is nothing complicated with this sign test. Somebody asked me about this, that is why I explained this. So, is it clear?
Sir,
Is it clear?
sir, actually the sign test was there in one sample test also, right? When the question was asked about in which format we want to do, first sample or second sample.
First sample is sufficient.
What?
First sample, actually the question is not clear. What do you want? First sample or second sample?
No, actually the sign test which is in the one sample test also, right?
Yeah, of course. There are two variants in science sample test. Of course, of course.
If the question in the question paper didn't ask it is in first sample or second sample, in which sample we want to solve the question.
In which sample the number of items more, that is to be considered.
Okay.
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 Sir, one quick doubt in this question, sir. So, we have 8 trials and one is 0. We eliminated it. Then we have 6 trials,
No,
of which
you have
6
7 trials and out of which 6 were successful, isn't it? 8
yeah,
total of 8 trials are there. One is tie. That is why we eliminated one. Then there remains 7 trials, out of which 6 were successful. Correct.
yeah, we are for R we consider only the positive ones.
Yeah, only
Right,
positive.
sir?
Yes, yes, definitely.
Okay.
We consider only positives are successful signs. That is why we consider positive.
Okay, and N becomes 7 because those are the total number of trials.
Yeah, of course. If there is only 3 positive figure, then out of this 7 we consider 7 trials and 3 successful. Okay, then R will be 3. N will be 7 and R will be 3.
Okay, sir. Clear now. Thank you, sir.
Okay. So thank you everybody for your cooperation. Okay, we have to do some more questions regarding this regression analysis. Somebody asked me through personal message that he wants to have discussed with these regression topics. So we can do that in the next class. Now I think almost this hypothesis is over. We can consider the regression analysis in the next class. Okay, thank you everybody. Thank you.
Thank you, sir.
Thank you, sir. Thank
Thank
you.
you,
So
sir.
everybody put your attendance here, okay, in the group, okay. Don't forget that.
Okay,
All of
sir.
you should put your attendance in the group.
Sure,
Yes,
sir.
Okay.